Wrap tokens are really important in all blockchains that support smart contracts. But what are those? How do we use wrap tokens? Why do we need them? And why are they created? My name is Andrew. Let's start. Before we start, I want to show you my Void.management project. So that's my new project in crypto space. You can go there, you can look at my application. It's fully decentralized, so yeah, kind of like that. I'm gonna make a separate video, but for now, just go to Void.management, subscribe to my Twitter, look at the products, and yeah, kind of like that. But once again, I'm gonna make a separate video. Okay, Void.management. The domain is really simple. Now let's go to my Remix ID, and first of all, I'm gonna say that you need to know everything about ERC20 tokens, and I have a separate video for that, but for those of you who don't want to watch it, ERC20 token is basically a common interface for tokens in Ethereum. So what if you want to work with banking applications and you want to work with some sort of a game? Both banking application and the game may have some sort of a token. And for all the programmers on Ethereum blockchain, ERC20 was created for all the programmers. Because ERC20 is basically a common interface, so I know how to transfer, what will transfer do, I know what will transfer from do, I know how to get the balance of my user, I know everything. And for me to work with the tokens, I can use ERC20. Kind of like that. Just a common interface for all the programmers on Ethereum. Now let's go to wrapped tokens. But before we start that, I want to show you my diagram. So we have BTC software here and we have Ethereum software here. And basically what is that? When different computers, different servers gather together and run some sort of a program, which is called BTC software, they create a node in the network. So 1, 2, 3, 4, 5. We have 5 nodes here. And all the nodes together create a blockchain. And that blockchain is fully decentralized because there is no central party here. All of them run the same program. But there is a difference between BTC software and Ethereum software because, as you can see, BTC software here and GETH here, so get. GETH is called Go Ethereum. It's a node for Ethereum and it's fully different from BTC software because those are two different programs. So Ethereum runs one program, BTC software is another type of program. And why is it important? Because what if I want to use Bitcoin, so Bitcoin, the native token of BTC software, let me choose a pretty image. Okay, that's alright. So what if I want to use the native token of Bitcoin software, BTC, in my Ethereum blockchain? First of all, why would I want to do that? Because if you look at Ethereum, we can write smart contracts here. So we can write applications that have decentralized logic, and we may want to use Bitcoin in that decentralized logic because that's the most popular cryptocurrency. However, there is a problem. I can't really connect Bitcoin software with Ethereum software because once again, those are two separate programs. And that's the problem called interoperability. And what if I want to use Bitcoin and Ethereum once again? I cannot really do that because I cannot send, for example, one Bitcoin to my smart contract in Ethereum because those are two separate blockchains, two separate programs. However, what can I do is get Bitcoin, lock it somewhere, and have a wrapped token. Wrapped token is basically a ERC20 contract, that has some sort of an underlying asset behind it. So what we're doing here, we have BTC, we use ERC20, so that common interface for all the programmers, and all the programmers know that we can transfer from, we can check the balance and all that stuff, and we wrap our Bitcoin, so our native Bitcoin from Bitcoin software, inside of that ERC20 token. And then once we have that VBTC, so one wrapped Bitcoin, VBTC wrapped Bitcoin is equal to 1 Bitcoin. But the main difference is that VBTC is just a ERC20 smart contract. Once we have that VBTC, we can normally use it in our smart contracts as we would do it with other tokens, with other smart contracts. So once we have our Bitcoin inside of our ERC20, we can just use it. And once again, 1 Bitcoin is 1 ERC20. The main difference is that Bitcoin is native to Bitcoin software. It's just a token. But ERC20, VBTC, ERC20 wrapped Bitcoin is a smart contract. That contract. Here it is. Contract. The main difference is VBTC. And 1 VBTC, 1 wrapped Bitcoin is 1 Bitcoin. So they are equal in price, in value, and in all that. In price and value. But the difference is that wrapped Bitcoin can be used inside of Ethereum. So once again, when we want to use Bitcoin inside of Ethereum or inside of Binance Smart Chain, inside of EOS, Tron, anywhere, What we're doing is we get our Bitcoin, we will lock it somewhere. It may be some centralized party, it may be some, I know, there are lots of ways of how you can do that, but we lock it somewhere and we get the same value in wrapped Bitcoin. So for example, if I have 10 Bitcoin, 10 here, I will receive 10 VBTC because those are the same in price. We cannot use our normal Bitcoin because it's locked, but we can use our wrapped BTC. And that means that we have the same value, but we moved our Bitcoin from our Bitcoin blockchain to our Ethereum blockchain. And now we can use it in smart contracts or do, well, lots of stuff. Different blockchains have different advantages and disadvantages. And if you want to get one token from one blockchain and move it to the other blockchain that has some sort of an advantage, you can use wrapped tokens. Of course, if that blockchain supports smart contracts, but almost every blockchain now does that, except for Bitcoin. Okay, so that's how it works. We get our real asset, we wrap it around our ERC20 standard or any other standard. For example, if you're talking about Binance Smart Chain, that's going to be BEP20, so BEP20, but it's basically the same as ERC20. So basically, we wrap it around some token standard and use it as a normal token. That's how it works. And of course, we can use different assets. For example, we can use gold. What if you want to use gold in Ethereum, like real world gold, real bricks of gold? We can, okay, those are bricks. We can get those bricks, log them somewhere, and then have something like VGold. And one VGold token is going to be equal to 1 kilo or 1 pound of gold. It doesn't matter. So you can create it like that. Any asset can be wrapped. The main idea is that you wrap your asset in order to easily work with it. And now what are we going to do is, you've probably already seen it, we are going to create a wrapped Ethereum. But that's the case. Okay, why do we need wrapped Ethereum? Because wrapped Bitcoin, we get Bitcoin from one blockchain, we move it to another. Wrapped gold, we get something from the real world, we move it to our blockchain. But why would we need wrapped Ethereum? Because Ethereum is the native currency of Ethereum blockchain. We already have it in here. But we want wrapped Ethereum token in order to easily work with it. So if we're talking about native Ethereum token, so native Ethereum inside of Ethereum blockchain, what we can do in smart contracts is use something like address, so our address dot call, then value 1 ether. That's how we can transfer 1 ether to some sort of an address. That's not really convenient for programmers. You can use it and it is convenient, but when you work with different tokens, it's going to be just easier for you to work with the same standard. So the main idea of wrapped Ethereum, is that we want the same standard for all of the parts of our program. So if, for example, you want your USDT to be exchanged to Ethereum, you can exchange your USDT to Ethereum, but it's going to be much easier to exchange it from USDT to the Ethereum, so to wrapped Ethereum, because the value of Ethereum and wrapped Ethereum is the same. But the main difference is that you can use all of the functions from ERC20 inside of that wrapped Ethereum. So it's just easier for the programmers and for our smart contracts. Kind of like that. And of course, it eliminates lots of bugs because with those call functions, you can mess up. But with ERC20, you have the same format, the same interface for all of your tokens. And now let's create wrapped Ethereum. It's not really complicated because what we're going to do here is we're going to get Ethereum and we're basically going to wrap it inside of ERC20. And we're going to call it W Ethereum. So you can see that the name is W Ethereum, contract is ERC20. We already wrote all the functions in the last video. The only thing that you need to do now is create a constructor, constructor. Okay, here we can assign name as wrapped ether. Then we can assign decimals as 18. So Ethereum has 18 decimals by default. Then symbol. If you don't know about decimals and why do we need those, once again, watch my last video. And symbol is going to be wrapped Ethereum, so WETH. Now, what do we need to do? We need to create two functions. I want to deposit my Ethereum and I want to withdraw my Ethereum. So what's going to happen? I'm going to send a real Ethereum, like the native token, and I'm going to receive wrapped Ethereum. Or I'm going to send wrapped Ethereum and I'm going to receive real native token, so real Ethereum. So I'm going to have two functions. The first one is going to be deposit. So what is it going to be is external payable function. And that basically means that external is the same as public in other languages, but external can only be called on the it cannot be called inside of the contract. So for example, transfer cannot call deposit, but any other entity can. So it's only for the external contracts. And payable means that our deposit function can receive some Ethereum. So what does that mean? Function deposit is going to be external and payable. So we will send some Ethereum to that function. So for example, I send 1 Ether. Okay, then I'm going to receive 1 wrapped Ether for that 1 Ether. So how does it go? How is it going to work? Balances from MSG sender. So the person who sent the Ethereum is going to be plus equals to MSG value. And that's it. That's basically it. So what's happening here? We deposit our money inside of our contract, and MSG sender is the person who sent the money. So the sender of that transaction. MSG value is the amount of Ethereum that we sent. And one wrapped Ethereum is equal to 1 Ethereum. And what we can basically do is just increment our balance by MSG.value. That's it. That's the only thing that we need to do in order to receive some wrapped Ethereum. Now let's quickly check it. So I'm going to go to my deploy and run transactions in my Remix IDE. Okay, deploy. And inside of here, we have deposit function. So you can see it right here. Now let's go to our value. I'm going to send 10 Ethereum here. And let's deposit our Ethereum. So it says that everything is all right. That was kind of a cool transition. I didn't do it, but okay, I cannot. Okay, here it is. We deposited our money. And now if I copy my address and go to balance of here, put my address in here, check my balance. Okay, I'm going to see that my balance is 10 Ethereum because I sent 10 Ether to my application. Kind of like that. That's how it works. Okay, now what I'm going to do is but I'm going to add another function called withdraw. So now we can add some wrapped Ethereum to our account. Now let's call a function called withdraw. Withdraw, like that. It's going to be an external function as well, but it's not going to be payable because we will not receive any real Ethereum. We're not going to send any real native tokens. But what we're going to do is we're going to have an amount here, integer amount. And that amount is going to be equal to the amount of wrapped Ethereum that we want to sell or withdraw. So how does it going to work? First of all, what we need to do is require balances from msg.sender be greater or equal to amount or not enough wrapped Ethereum. What does that mean? Require is a function that basically requires your condition to be true. That's the condition. And we're saying that balance from msg.sender, so balance of the person who sent the transaction, should be greater or equal to the amount. Why is that? Because what if I have 10 wrapped Ethereum, but I want to get 40 wrapped or 40 Ethereum? So I don't have enough money or enough tokens in order to get it. But balances MSG sender greater or equal to amount will check for that. And if that's false, we're going to receive an exception called not enough wrapped Ethereum. Kind of like that. Okay, so we require that. Then what we need to do is use balances msg.sender minus equal amount. Because once again, we check that our balance is, or the amount that the person requested is lower or equal to the balance of our sender. Then we need to remove that balance from our account because I want to withdraw some tokens. And then what I'm going to do is msg.sender call, put the curly braces, and send value as amount. So what are we doing here? We require our amount to be lower or equal to our balance. Then we decrease our balance by that amount. And then I'm using msg.sender call from value amount. That basically means send amount to my MSG sender. So send amount of Ether to my MSG sender. But what's important in here is that that function may fail. And in order to check that it's not failed, in order to check that everything is alright, what we need to do is put parentheses, create a boolean called isSend, and put a comma after that, because it returns some byte data as well. So isSend is going to be true if the Ethereum was sent, and it's going to be false if there was some sort of an error. Then we require our isSend to be true, or not enough native tokens. Okay, so basically that means that message.sender.co will send some money to our message.sender. But is sent is going to be true if the money was sent. And if it's true, then require true is going to work fine. Everything is going to complete, you're going to have your Ethereum. But if is sent is false, that means that msg.sender.co failed for some reason. And require is going to be false. And when require is false, we revert our transaction with not enough native tokens as an exception. Kind of like that. And we can see that there is some sort of an error, different number of components, left-hand side, right-hand side. Type function bytes memory, payable return, boolean bytes memory. That's actually really interesting because I put a comma here. So boolean send, I don't really know, maybe I need to save it again. Let's go to errors. So it says that we have different number of components, so different number of variables here and here. Okay, I know what's the problem. I just forgot to put parentheses here. So after you call your call function, you need to put parentheses, and then and then you need to put an empty string here. Okay, now it's gonna work. So we just sent an empty bytes. So msg.sender.co value amount parentheses string in here and boolean sent comma. That's gonna work. We don't have any errors now, and let's deploy our contract. Deploy. Let's go here. Let's look at it. We have deposit approve. The first thing that I'm gonna do is deposit some ether. So 10 ether is going to be deposited to my account. Boom. Okay, we don't have anything in here. Okay, deposited. Then let's go to our accounts. I'm going to copy the account and let's check our balance. Balance of is around 10 Ethereum, kind of like that. Then let's withdraw some of that money. So I'm going to withdraw some GUI. Okay. No, that's okay. You're just gonna have to look at it like that. So balance of is, yeah, you can see we got some GUI from our account. So now we don't have as much money as we used to. Let's send something like 30 ether. Deposit. Okay, now we have 50 ether in our account, and let's withdraw all of the money from that account, from that wrapped Ethereum. So withdraw, and you can see that we are back to 89 Ethereum. And yeah, kind of like that. So we got all of the money back, and if I want to, I can deposit my money. So basically what we have done here is once we want to deposit my wrapped Ethereum, I just send the money using deposit. Once I want to withdraw, I just withdraw with withdraw function. Nothing complicated. So when you deposit, you increase your balance in wrapped Ethereum. You can use it in other contracts. You can send your wrapped Ethereum to other people. You can do all sorts of stuff as you would do it with normal ERC20 tokens. But once you want to withdraw it, you just go withdraw with the amount in here, and you receive your Ethereum back. Kind of like that. We have 89 because I redeployed the contract, but yeah, so I redeployed the contract. I sent 10 Ethereum to the first version of wrapped Ethereum, and then I created the contract once again with withdraw function. So that's why we don't have 100 Ethereum, we have 89 as the final result. Kind of like that. So that's about wrapped tokens. Once again, thank you for watching. My name is Andrew. Go to void.management. Boom, right here. And yeah, kind of like that. So thank you for watching. My name is Andrew, and bye bye.